one of the when I just started the recording. They might have some standardized tests, and the every once in a while, like one of the major ones in the United States is the SATs. You might have heard of them, but I'm sure every country has their own standardized testing. Every municipality, every county, right, have their own standardized testing. So here I am. I'm building an application that is going to be used. I'm building a backend that is going to be used by in one of those testing situations, right? So the my job was to basically interact and integrate an external API endpoint that was going to provide some sort of a authentication service. I can't remember. It's been quite a few years, but it was supposed to provide some sort of authentication service or some sort of tokenized mechanism that students, upon sitting down and trying to take those tests, they needed to log in to the system, get some sort of credentials that could then basically behind the scenes to facilitate their testing, their test taking, and then submitting their results right to our backend. So weeks prior to rolling this out, I get documentation from the third party service provider. They're providing an API that I'm going to be interacting with, right? So my backend is supposed to be talking right over HTTP to this sort of a REST API, right? So and I'm feeling pretty jazzed up. I've got concurrency in my tool belt. I'm ready to launch hundreds of Go routines. I'm just excited, right? I've been learning Go and using Go, and I'm just excited, right, to get this going. So, and as every engineer should, I know that okay, during testing, right, I'm going to be doing my unit testing. I don't want to be hitting right this third-party service, right, as I'm running my unit tests, right? I run, dozens of unit tests throughout the day as I'm trying to code my application. I don't want to be talking to this, third-party service and basically using up our quota and whatnot, right? I don't want to be sort of peppering this service. So like every developer, that I knew of, does, they mock up, right, this third-party service, right? They stub it out, they mock it out. So I've basically I'm talking to a fake backend, right, in my unit test, and I create this fake backend, right, this fake service by looking at the documentation and seeing what responses are supposed to be, right. So I'm emulating, right, the possible responses that could come from interacting with this service. And I put this thing to staging. Everything works great. I have I'm firing off Go routines wherever I need to. I'm simulating scale and everything else. Everything is working out perfectly. That's all in testing, right? So, if you've been in the situation before, you kind of know where this story is going. When I put this into production, right? The day comes and we are about to roll this out, right? And the students are about to come sit down to take their test, and we're talking like a county-wide kind of thing, right? We're talking like hundreds of students, at least 8, 9, 1,000 students, basically taking this assessment. And my piece of software is on a critical path, right, to them being able to, take their assessment. Okay. Now, what I didn't anticipate, right, was although I tested my backend, right, to be able to handle that kind of load. And this is something you should always be asking, right? Whenever you sit down to write a service, somebody says, hey, you need to be able to build this thing. Some of your questions must include what kind of a load must I anticipate, right? How many requests per second should I be, factoring in here, right? So these are questions you're asking yourself as you're designing and architecting your software, because it's not all one size fits all, right? Go is great, but you still have to do some thinking. You still have to design your architecture and have some sort of reasoning behind how you build your services, right? So even though I did that, right, I'm like, okay, well, what should I expect here? In terms of scale and sort of the number of users, how many requests per second should I be expecting here, right? I did that due diligence on the front end, right, talking to my own customers. But what I failed to do, right, was to figure out, right, on the where the system I'm integrating with, what their capacity was. So what ended up happening is that you have all these students sitting down, right, logging into the system, hitting my backend, right? It's on a critical path to all of these students trying to log in simultaneously at the same time, right? Now, I'm receiving these requests. My system is handling it beautifully, right? Like it's I'm seeing everything. Everybody's coming in. They're making their in my logs, right? I start seeing a bunch of 429s, but the 420s are coming back from the system I'm integrating with. So these students are trying to log in. They're hitting my backend, right? And on the critical path to be able to them moving forward and proceeding and taking their assessment, I need to call this third-party service, right? But then I'm relaying all of these requests to that third-party service, and the third-party service is just buckling down, or it's protecting itself. It's sending back a bunch of 429s back to me, right? Some requests are making it through, some are not, right? So now I'm like, I start scratching my head. I'm like, oh my goodness, what did I do? Right? I start panicking, right? I'm not trying to figure out, okay, what the heck just happened, right? I tested this thing, like I made sure everything, we would be able to scale to the demand. What happened, right? What happened was I didn't go far enough in my due diligence with the integration with the third party, right, to figure out, okay, what are the constraints and limitations, right, that are placed on me by this external system that I have to integrate with, right? What constraints do I have to deal with on this side, right? It's not just your ability to fire off a bunch of routines and do a bunch of work. You are always constrained, right? You need to constrain your concurrency, right? So that you are able to sort of be a good citizen within the system, within an environment that you're working with. So here I am pummeling this other third-party system with requests. Some of them are succeeding, some of them are failing, right? No doubt they have some sort of a throttling going on. Maybe I'm exhausting some sort of a buffer, whatever the case may be. Some are failing, some are succeeding, right? And now some students are able to make it in, some students are not. Throughout multiple sort of retries, every time a student tries, they fail. The instructor on site basically tells them to try again. So thankfully, right, within a matter of about an hour or so, enough students have trickled in, right, that they all managed to make it in, right? Because again, remember on the integration side, some requests succeed, some fail, right? But if I send too many requests at one time to that third-party service, chances are I get back a 429. And for those who are wondering what a 429 is, it's an HTTP status code for too many requests, right? So that backend is protecting itself, right, by sending my server requests a response of 429 saying, hey, you sending too many requests. Now, what I should have done, right, is what I'm going to be going through with you throughout this particular tutorial, right? So we're going to start small. We're going to start with, okay, what happens when you don't have any resiliency, right, in your clients and your servers, right? And we're going to see what Go offers you out of the box, right, to start introducing resiliency in both in your client side and your server side, okay? So if you're excited, so am I. Let's get into this. So I'm sharing my screen here still. So I'm going to go into, I have a, so just so I don't have to keep switching between my local editor and in the browser here, I just basically have this repository, right? This going through each repository, this code. I just have it loaded up inside of a GitHub code space. Okay, so this is the same code you're looking at here. That's what's in the repository here. It's the same code you're looking at here. So in the 06 HTTP resiliency folder, right? This is where our journey starts. Okay, so we're gonna go into the first thing I want to talk about is on the server side, right? We're going to go on the server side, and then we're going to work our way on the client side, and then we'll close out again on the server side, okay, when we talk about backups and things. So on the server side, let's start with the context example. Let's talk about, let's open up the main.go in the none, right? So HTTP resiliency, server, context, none, okay? So the reason why we're starting here is because you are, right, no doubt, going to be tasked with not just writing HTTP servers, but you're going to be tasked with writing HTTP clients as well, okay? So imagine that you are tasked with writing an HTTP server, right, that is going to receive requests from a client, right? And those clients could be, it could be somebody on their desktop with a stable connection to you, or they could be somebody on a mobile device, right? In the best case, they have a steady connection, right? In the worst case, somebody goes through a tunnel while they're driving in the highway, their connection, right, whatever request they've made to your server just drops, right? They might come back, they might not. But the situation is they have an intermittent connection kind of situation going on, right? So you're tasked with writing a server, and this is a very simple server. It just provides a greeting, right? Your task is to write an HTTP server, right, that returns a greeting, okay? Now, this is the simplest thing that could work. Again, I'm keeping the examples very simple here, but obviously this is same basic principles, right, that apply to any level of sort of a sophistication layers you want to add on top, right? So basically, all I have here is just a simple greet handler, right? Basically, this follows the HTTP the service HTTP interface, right? You're gonna receive, a response writer, and you're gonna get a pointer to an HTTP request, right? And when I do a listen and serve, right? When I call HTTP package listen and serve, I'm gonna have or rather I'm using the default server mux here to basically say, hey, any request that comes in to my server, I want to have the greet handler handle that response, right? So any request I send in is just gonna be handled by this particular request, this particular handler. So inside of here, however, right, I have a timer, right? This is simulating. So imagine our greet handler is doing some heavy lifting, right? It's doing some work, right? It could be in our case here where we have a hard 10-second sort of limit, right? Or rather a timer, right? On our handler. So a client is going to make a request to our server, right? And this particular server handles very heavy tasks, right? Imagine that your greet handler needs to talk to a bunch of other microservices behind the scene, right? Imagine that, credit cards need to be processed, inventories need to be checked, right? There's a lot going on, right, in this particular request, okay? So let's actually run this server, right, and simulate a client connecting to your server, right, and simulate best case and worst case, okay? So I'm going to pull up my terminal here, right? Now I'm going to do the go run. And this is going to be the 06 HTTP. I need to make targets for this to make them easier to run. And then we are under the server, context example, none, main.go. All right. So here we are, right? So this is our server. Our server's running. Okay, it's just sitting here waiting on the HTTP listen and serve, blocking call, right? So, our terminal, we're not back to our prompt. So I now need to open up a new terminal, right? And let me make this a ZSH terminal. There we go. So let me see, can I make this side by side? Can I have these side by side? Yes, I can. Great. All right, let me collapse aside here. So on the left-hand side of this terminal, all right, we have our server, our HTTP server. On the right-hand side, I'm about to simulate a call, right, to our running server. So this is going to be localhost, right? I'm running on localhost 8080, right? Just hitting the root, right? And I'm going to do, let me add a -i in here just so I can see the responses that come back. So I make the requests, right? I hit enter, right, on my curl here, and you see my server's thinking, right? It's basically saying, hey, every up until that 10-second elapses, right? I'm just iterating. I just have infinite loop with a select statement, because what the complete after basically here is a channel that I'm trying to read from. Okay, so hopefully you have enough context to understand how channels work. So basically, all I have here is basically I have a timer, right, which is basically when I call time that after, I'm going to get back a channel, right, which is going to return back a value of time. Something I know the moment the time elapses, the 10-second elapses, I'm going to be able to read from the channel, right? And until that 10-second elapses, this call here is not going to execute, right? So that means this is me simulating when the work is finally done. Okay, so this call is going to block until, right, the 10-second elapses. But since I don't want to block on this call while waiting for the work to be done, I'm just falling back to the default case here and saying greetings are hard. I'm thinking, right, this is why you're seeing the repeated greetings are hard here, right? So I'm simulating a long running process. Okay, and finally, right, after the 10-second has elapsed, I print out hello gopher, which is what you're seeing at the bottom here, right? Basically, I say, hey, I handled the greeting. I handled the greeting request, right? So the server, right, is done with, did I, listening, context, none, right? So where is greetings are hard? Handle, yeah, there you go. This is what I'm seeing here. So handled greeting request. So this defer logged up print line, right, is this handled greeting request here. Okay. So now you saw how it took basically I took all 10 seconds to do this work, right? So now, right, and I get my hello gopher back, on my client side. So I get to 200 okay on the right hand side, right? All is well. This is happy path. Okay. Now we have a situation where somebody's on a mobile device, same situation I illustrated before, right? Now they're going through a tunnel, so their connection is about to be dropped. Okay, so I'm going to simulate that by issuing a scroll again, but this time I'm not going to wait for the whole 10 seconds to elapse. I'm going to cancel the client side's request, right? But let's see what happens on the server side. So I'm going to clear the server side, right, on the left-hand side. So now I'm going to issue this curl call again. Now, the work is happening. So I'm going to control C, right, and terminate my curl client request. But you see what's happening on the left-hand side here? The server's still working. I no longer have a client that cares about the response, but my server is still working. So if you've got, this is a long-running process, you're hitting databases, you're doing all kinds of calls behind the scenes, your server is literally still working for a client that will not be there for it to respond to. So this kind of situation we want to avoid, because you're using up resources, you're doing things that there's not going to be anything there to respond to. Nobody cares, right? Because the client that asks for this is gone. The client is out, right? I prevented this whole chain, the happy path from happening by simply basically having the client drop the connection request. Okay, so this is sort of our first foray into one of the things that the standard library gives you out of the box to handle these kind of situations. Let me cancel, right, the server side now. Let's now go in and bring the context example. Let's add request context. So let's open up the main.go, right? So let's put these side by side. So on the right-hand side, I'm going to have the no context, right? And the left-hand side, I'm going to have the one with context. So what is context? So if you've done Go for any amount of time, you're bound to run across context. It's virtually everywhere. Whether you're building HTTP applications or client side or CLI applications, context is it's so fundamental to writing Go code these days. Like, I'd be hard pressed to find a program that doesn't use context. Even if you don't use it explicitly, a lot of things under the hood are using it for you implicitly. Okay, so what is context? Context cares about propagating, right, cancellations. It cares about sort of allowing you, right, to have something that you can pass around in your application that should, right, a cancellation happen on that context. Everything that basically is aware of that context is notified so that they can now respond accordingly. If they need to clean up behind themselves, right, before a function exits or something like that, or before an operation is completed, whatever needs to happen to gracefully shut down your application, right? You can get that notification sort of carried along everywhere in your application that needs it. Okay, so that's context in a nutshell. Okay, it's not the formal definition, but the way I think about context is, how do I notify all the parties involved in my application? How do I notify them when something of import happens, right? I mean, if a deadline is exceeded, a cancellation happens, whatever the case may be, like that means stop working, right? Stop working, stop doing whatever you're doing, shut down cleanly, clean up after yourself, but stop working. Right. So how do we use this? How do we augment our existing server application, right, with this notion of a context? Well, we still have our timeout here, right? And now what we've initialized a context variable, right? Not initializing one using a context package directly, but using the one that you get out of the box from the request context, from the request that gets passed into the greet handler. So remember this points to HTTP request here. The standard library will give you access to a context that is part of the request out of the box, right? You get that for free. So it's already there for you to be able to use to leverage. So you don't have to do a context that to do or background or whatever it is. You can literally, or you should, get the request that is coming from the context. So what I'm doing here, I'm initializing this context variable, right? Getting the context from the request itself. And then now I've added a new stanza to my select statement here, right? So previously I had, waiting for the timeout to happen, right? So, I had the timeout and then a default case, right? So now I've introduced a new case to basically say, hey, When this context is done, right? So I'll be able to read, right, off of this done channel, right? The moment the context is canceled in some way, right? Either a timeout has been exceeded or cancellation has occurred, right? I'll be able to know, right, when in this case, the request context, right, which is triggered by the client making a request to your application, right? I'll be able to know when the client no longer cares because the client has canceled their request, right? The standard library will do you a solid and pass that notification on to you so that you can then react accordingly in your application, okay? So in our case here, all I'm doing is capturing the context error, whatever that case may be. If it was a timeline that has been exceeded or cancellation, I'll be able to capture that here. So that's the reason for the context cancellation, the context being done. That's the reason for it. I just print it out, right? But then what the opportunity I have, and I'm going to demonstrate this by simply running the program again. So now I'm running the context example with the context, and I have a main.go. So here we are, my server, same server, right? Now with the context in there. Now, what I'm going to do is I'm going to issue my curl call, right? So here we are, handling the greeting, thinking, right? So this is happy path, yay, right? 200 OK on the right-hand side. So I'm going to do the same thing again. So I'm going to issue this call, but I'm going to cancel it before the server has had a chance to respond. So watch what happens on the left-hand side. So I issue the request, I cancel the curl call, right? But guess what our server does differently this time around? You see this line says context error, context canceled. So that means I didn't have to spend all this time, right? Greetings are hard thinking, right? I basically short-circuited the process because I know I've been notified that my client, right, is no longer cares about this request. My server can stop doing work, right? I can stop wasting resources on the server, right? Because there's no client to receive a response when I'm done, right? So by using the request context, I can then sort of be smart and intelligent about how I handle the resources used by my server, okay? So that's the context, right? The introduction to the context, but it gets better from here, right? So now, and as I go, if you have questions, please drop them in the chat or, raise a hand. And we're going to be moving pretty quickly because there's a bit of material to cover and there's always not enough time to cover it all, right? So now what I want to cover is on the client side. Okay, so let's jump in the client side. Let me close these two examples here. So on the client side, let's talk about sort of the default resiliency. In other words, when you don't have any. Okay, so imagine that now you're on the client side. You've seen on the server side how you can spend time wasting resources when clients don't go care. Now you're on the client side, right? You're tasked with making a request to a server, which can be naughty, right? That server can be naughty. In this case here, I'm simulating that server by using the HTTP test package, right? And initializing a server, right, that I'm going to be simulating. So in other words, I don't have a separate program that I'm going to be running. I just basically have a test server here, right in line with my program, just to make life a bit easier for me. But what's happening inside of this test server, I'm instituting a random delay, right, up to 60 seconds. Right, so this test server is a naughty server. It can take up to 60 seconds to give me back a response, right, when I make my HTTP GET call, right, on line 24. Okay, so I'm calling HTTP GET again using the default HTTP client, right? So again, a lot of folks don't realize that when you use the HTTP package, you get some things out of the box by default, right? You get a default HTTP client, you get a default servmux, right? These things are initialized, right, for ease of use, but as we'll see later, oftentimes you don't want to use them as is, right? You want to initialize them and set some additional safeguards into place, right? That we're gonna get to, right? But for now, I'm just using the HTTP GET, right, to call on my test server, right? And we know the test server can be naughty because it can take up to 60 seconds to return on its whim, whatever the case may be, whatever reason why it takes so long, who knows, right? So that means my server as built, right, is gonna have to wait for however long this server decides to take. So if I run this program now, oops, I'm going to use the client side. So I'm going to do a go run. Actually, let's use the left-hand side again. Let's do a go run, and we are going to be on the client side this time around, and we are going to use nope, the default resiliency and main.go. So here we are, right? I'm making a request. So this is this log statement right here, line 23. I'm making a request. The server, right, has received the request. So this is this log statement right here, line 14. So the server has received the request. But my client now is at the mercy of the server, right? I literally, as designed, my client has to wait for the server to take whatever long it's going to take, up to 60 seconds, right, before it returns a response, right? So I don't know about you, but in some cases, right, you want to be able to sort of move on pretty quickly, right? If you make a call to a server and it's taking longer, because guess what? If a user using a front end, right, where you're providing a back end, right, if your user makes a request, right, the front end calls on you to provide some sort of response back to the user, and you have to integrate with some third party, right? So this is the situation we have here. You have to integrate with some third parties. So think about test server here as a third party. You have to talk to this third party, right? And this third party decides, for whatever reason, it's going to take a longer than usual time to respond. Guess what? Your user, right, who has no idea that you have to talk to a third party, is now sitting and waiting, right, on like two servers. It's waiting on the front end, trying to get a response back from your server, and your server is waiting on some third party server, right? Maybe you want the ability to control, right? You want some level of control over, right, how long this process is, right? You don't want to leave your user at the mercy of some third-party service, which, you know, in this case is a naughty server. It can take up to 60 seconds. Your user is going to be sitting and waiting for 60 seconds, right? So how do we get back some control, right? How do we wrestle some control back, right, from this situation? Let's open up the context resiliency. Again, context making a comeback here because it is literally designed for this particular use case, right? So here we are, right? I mean, turn on the terminal here. So here we are again, right? Same test server being naughty, right? But I've introduced a couple of variables here. So I'm calling on the context package. There's a with timeout version of how you get context. There's a couple different ways of getting a context from the context package, a few different ways, right? But this one, I'm basically saying, hey, I want a timeout, meaning that I anticipate that when my client makes a request to some backend server, to some HTTP server, right, that there's a certain amount of time I'm willing to wait, right, until I get a response back, right? And who knows how I choose to handle that timeout. Maybe I talk to a different server. Maybe I'll talk to no server at all and choose to provide some sort of response to my front end, for my front end to tell my user, hey, try again later, or whatever the case may be. But anything is better than forcing a user to wait 60 seconds, right? So I have a context here. I've initialized it, providing a timeout, right? So I need a base timeout for this. And this is where the context of background comes in. You're going to see this pattern a lot, right? The other ways you can get this base context, again, you've seen me get it from a request earlier. There's a context to do. There's various ways of getting this base context, but somehow if you don't have a base context, you can use a context background. The context to do is often used when you're still building your application. You don't know where the context is going to come from, but you're going to use context to do for now as sort of a like a reminder for yourself that say, hey, I need to figure out where this context is going to come from. But in our case here, we're using the base context, right, as to provide our context with timeout, because our context with timeout requires a parent context. So that's what that first value is. And then I have the amount of time, the duration that I'm willing to wait, right, for the request I'm about to make, right, using this context. Okay, this is after this duration period, right, your context is going to get canceled. Okay. So I have this cancel here that gets returned in case I want to sort of cancel this context early, right, prior to the timeout, right? I can do that here too. I can literally call the cancel and that will perform basically the same action. Okay. So now when I create my request, right, I'm using the HTTP package, calling new request with context, using the context I just initialized, right? And then I provide the other pieces, right? What HTTP method I want to use, what the URL is. Again, this is that about test server, right? And this nil value here. This nil value is here because I'm making a GET request, not a post request or a put request. There's no body to the request, so this is always nil when you're trying to do a GET. Okay. So now, when I issue my request, right, on line 38, right? Again, using a default client here to perform the request, right? So not using a HTTP GET or something like that. I'm using a default client here, right? That gets initialized for you from the HTTP package by default, right? To perform this request. When I perform this request, guess what? The request has this context, right, embedded in it. So now, let's see how our server performs. So now I'm going to do, let me move this aside a little bit so I can see the whole path. So I have a client and I have a context resiliency, main.go. So now let's look at what happens. Remember, I'm waiting up to 5 seconds, right? You see what happened here? Let's take a look. I perform this request and I'm checking to see if I'm going to get an error back. One of the errors I could get back, right, is if the context that is attached to my request is canceled. So that's what I'm printing out here. I'm printing out the client error, and I'm printing out that the client is moving on. So that's what you're seeing here. So I'm seeing that the client got an error, context deadline exceeded. My deadline that I set up on line 26. I was willing to wait up to 5 seconds for this request to get made and for a response to come back. That deadline got exceeded, so I got an error. Again, you can choose to handle this error, right, however you'd like. Make another call to a separate backend, right, log it out, or capture some metrics, whatever you need to do, capture your trace, do open telemetry, whatever you need to do, right? But now you have the option. You've wrestled back some control over this naughty server that could take up to 60 seconds to return a request back to you. Now you have the power. You control how long it takes, right? The whole process to take. Now you can return back something to your front end that says, hey, try again later, or however you want to handle that, right? So this gives some control back to you building a client, talking to those servers. Okay. Now, there are other ways of controlling resiliency, and I'm gonna mention them very briefly here before we move on to other things, right? We have to talk about retries and backups and all that good stuff, right? So there are some other things you can do for resiliency here. There is HTTP client resiliency, meaning that, remember what we were talking about, sort of using the default HTTP client when we're doing this call right here. So let's pull this up here. And then let's pull up the client resiliency, open that up side by side, right? So on the left-hand side, on line 38, right, we're using a default HTTP client, okay? There's a downside to using default HTTP client, right? If you don't specify, it can take a timeout. If you don't specify a timeout, the default HTTP client will make the request and wait forever, thereby simulating the same exact situation we kind of had before. Right? Because, and that's exactly what happened in our no resiliency version of the program, our default resiliency version of the program, right? When we did this HTTP GET, we were using a default client under the hood. The default client doesn't have a timeout on it. That's why we were forced to wait 60 seconds, right, for the response to come back. So don't use the default client as is. Matter of fact, I tend to basically say, if I see a default client use, unless you give me like a trivial program, a trivial example, and even in those cases, I tend to, I see that as a code smell, okay? What I want to see, right, is not the use of the default client, but I want you to at least think about, right, on the right-hand side here, I want you to initialize an HTTP client and give it a timeout. And this particular timeout encompasses the whole sort of interaction. So an HTTP request has multiple pieces to it, right? And there's actually an article, right, written by one of the good folks within the Go community. You might know of them, Filippo, right? This article, I'm going to link that to the chat here, right? And in this article, right, he talks about the different aspects, right, of the different timeouts, the different portions of a typical HTTP interaction, right? And there's also one for the client side, right? So these are all the pieces that are involved, right? From the time you say, hey, perform this request, right, to the time the server gets hit and you get back a response. These are all the pieces involved in the process, right? And there's timeouts at different level, right? There's the client timeout. There's the TLS handshake timeout. There's the idle connection timeouts. There's different timeouts involved in your HTTP request here. So let me drop that in the chat so you have access to it. Where did Zoom put my chat window again here? There we go. Hidden. There we go. Boom. All right. So here I'm setting up a timeout sort of for the whole end-to-end flow, right? When I set that timeout at that level, right, I'm setting it for the whole end-to-end flow. From the time request is made to the time response comes back, I'm basically saying, hey, this is how long I'm willing to wait, right? So at the very least, when you're using an HTTP client, set this timeout at the very least. Otherwise, the default client does not have a timeout. You'll be waiting forever. Unless, obviously, you follow the approach of having a context, right? At the request level, right? Then even if you do use the default timeout, the default HTTP client, the context will take care of timing out the request for you. But that is one of sort of the one approach. But definitely, I highly encourage you to initialize your own HTTP client and not rely on the default client, at least for production code. Okay. So the other piece I want to mention here is transport level resiliency. So remember how I was talking about, sort of the different sort of aspects here. There's a transport timeout, TLS handshake timeout. You have control over those things as well. So when you initialize an HTTP client, you have the opportunity to provide a transport. You can initialize your own transport, meaning that you can say, hey, I'm willing to wait, in this case, up to 10 seconds for the TLS handshake to occur, right? The TLS handshake is one of the portions, right, that happen in your typical HTTP request, right? And then you can also provide other sort of properties like the maximum number of idle connections you want to have, right? And your connection pool size and things of that nature, right? So this is where you get to initialize your own transport, provide some finer grain, right, configuration, right, that you then hand over to your HTTP client, right, which can have its own timeout, right, and also have its own transport with its own level of timeouts. Okay. So you have lots of knobs and lots of levers here, right, to control, right, your client making requests to a server and how it handles, how long it waits for different aspects of that request to happen. Okay. Now, all right, moving along. Where is it? There we go. So now let's talk about. So if for those following in the wiki, we're going to talk about, jump to the resiliency section here. Let's jump to rate limits, retries, and backoffs. And this is where, if you recall the story I told at the beginning, this is this stuff I wish I knew, right? Before getting bitten really, really badly, right? By effectively getting throttled, by my client effectively getting throttled, right? And not doing enough diligence to understand what my constraints were, right, with the system I was supposed to integrate with, right? Spinning off a bunch of Go routines, all of them trying to hit the server all at once, right? And that got me in trouble. Okay. Just because you have great power in Go routines doesn't mean you should, abuse them, right? Or rather, you should know how to use them properly. Right. So we're going to talk about rate limits, right? So I'm going to show you how to implement rate limits on the server side, right? But also I'm going to teach you how to actually do backoffs and things, right? On the client side, when you start running afoul of those rate limits on the server side. So let's talk server side first. Let me close some windows here. All right, so let's talk server. Let's talk backoff, open server. Let's do main.go. Okay, so we're on the server side, right? We're tasked with implementing very basic, right, some form of rate limiting, right? So as you go through this, you're going to be saying, oh, can I rate limit per client, or can I do, like, absolutely, right? But this is a very basic example that basically is no matter how many clients hit me, right, I'm tracking one limit, right? This is very rudimentary, very basic, but it does illustrate the point of how to implement rate limits, what goes into implementing rate limiting in your servers. Okay. So first thing I'm gonna mention here is that in the Go community, you're gonna find a ton of different libraries that implement, backoffs, retries, rate limiting. There's gonna be a few things. There's gonna be different algorithms for the rate limiting. There's only all these other things, and that's fine. That's perfectly fine. Like 3/4 of them, if not most of them, are based on this package, this golang.org/x/time/rate. This package right there is sort of the fundamental, right? Gives you sort of a near standard library. I say near standard library because it is part of the experimental packages of Go, but a lot of packages have graduated and often graduate from the experimental phase into the standard library proper, right? A lot of times they end up living there indefinitely, and that's fine too. But this package is solid. I use it in production all the time, right? So have no fear. Just because it's experimental doesn't mean it's not ready to go. It is production grade. It is well untrodden ground. It's solid. So use it whenever you need to implement some basic rate limiting without having to bring in third-party packages into your world. Okay. This is the SRE me speaking. I'm very third-party package shy. So again, if I can do something with the same library, that is my default go-to before I look to other solutions. Okay. So we have this rate package here that we're going to be using, right, to initialize ourselves, right, or rather to declare, right, a limiter. Okay, we're going to be initializing this limiter in a second here, right? But we're going to declare a limiter that is of type pointer to limiter, right? This limiter has a few things on there, right? It has it's going to have a limit and a burst. These are the two things we're going to pay attention to in this particular at this time. So the limit, right, represents the number, right, of requests you can actually have per second. That's your request per second limit, right? So whenever you see documentation that says, hey, you can only submit 100 requests for every 15 seconds or whatever it is, right? Just do the math, break it down to your head, say, okay, what does that effectively mean for requests per second, right? So that becomes, right, the constraint that you have to work with. Okay, so on this side, you're on the server side, you're basically saying, hey, how many requests am I allowing per second, right? How much can I handle? Okay, and again, you can have lots of different servers, each following this preset limit, but the limit here basically says how many requests can I be processing at any one time. The burst, right, is sort of the allowance, the little buffer that you're allowing your client, right, to be able to perform, right, before you start basically preventing further requests from actually making it in, right? So think of it as sort of a grace period, like a buffer you're allowing, right, to additional requests to come in beyond the limit, right? But the moment that burst is exhausted, right, you're back to being you know, like sort of like taking a hard stance, right, with your limit. Okay, so oftentimes, right, you know, clients will basically experience a burst on their end, right? You're just basically being graceful, right, to your clients and their needs by also providing a burst. You don't have to, right? But in some cases, it's useful to have a burst. So these are the two things you really care about, you know, with our limiter, right? The number of requests per second managed by the limit and the burst. Okay. Now, you need a middleware, right? Typically, right, you will implement this through middleware. Again, we're building an HTTP server here. Requests are going to come in, right? It's a natural place to put, you know, a rate limiting, right? Before the request actually makes it through to other, you know, sort of business logic or anything like that you might be doing, even before it hits authentication or anything like that, you may want to implement rate limiting right then and there, right at the edge before more actions get processed, right? So what we're doing here, so before I talk about the handler and the middleware, and again, you've seen middleware before. This is nothing more than basically the asking the limiter here to say, hey, when the rate limiter is no longer allowing, right, based on sort of the limit being exceeded and the burst being exceeded, right? When I'm no longer allowing a request to come through, I want to provide some sort of response back, right? In this case, I want to send back that dreaded 429, right? So basically, all the requests are coming in. My middleware is sort of filtering out or seeing all those requests come through, right? And the moment my limiter says, "Oh, I'm out of room," that's it. The club is closed. You know, y'all standing outside in the line until somebody comes out, right? Nobody else is going in, right? This is our limiter enforcing. That's the door bouncer right there. Basically say, hey, nobody else can come in unless somebody else comes out, right? So this is what we're doing here. So this effectively a line like this, right, is what caused me so much grief, right, when students were trying to use my system to take their standardized testing. Literally, a single line like this might have very well been the reason, or something like it, was the reason why I would intermittently get a 200 okay, successful processing, or a 429, right, telling me, oh, too many requests. This is exactly where I got caught. Okay. Now, let's talk about the rest of the implementation here. So all I have here is this a port, right? What the default rate is. When I run this program, I can provide the default rate, a default burst, right? And then I have my limiter here that I'm initializing based on the rate and the burst, right? And then basically I have so I'm using not the default serve monks, but I'm initializing my own serve monks here, providing a handler func here, and basically saying, hey, if everything goes well, right? If the request come through and the limiter allows it, we're 200 okay, we're good, right? In any other case, right? Again, every request going through a rate limiter, like on line 45 here, you can see where I'm wrapping my muxer with my middleware, right? Again, this is typical middleware sort of a mechanism, right? I'm wrapping my muxer with my middleware. So every request goes through my middleware, right? So the moment I run out of room, right, I'm returning back a status too many requests. Okay, so now let's see. And I know I'm running out of time here, so I'm gonna move through this pretty quickly. So this I have this make file here inside of this this server folder, right? You can actually use to simulate. It's just gonna issue 6 requests, right? It's gonna say in quick succession, right? Thereby guaranteeing that I'm gonna run afoul of this limiter, right? So let me quickly do a go run, and I'm gonna do, this is gonna be server, and this is gonna be back off example, and this is gonna be let's do a main.go here. Okay, so my server, right? See, by default, 1 request per second with a burst of 3 requests. So I can allow, right? There's a set number, there's a maximum request that I can issue. Okay, so let me go into this folder here and go into server and go into the backoff example. Where are we? Let's go into server. Okay, so I have my make file in my main.go. So I'm gonna call this make target, right? The default target here. So you can see I'm just gonna basically just doing a quick bash here and doing a curl call against my server, right, in quick succession, right? So I do that, and you can see, let me create some more room here. You can see on the right-hand side, right, how well my throttling worked, right? So the first request that I make, I'm good, 200 okay, right? Second request, still good. Third request, still good. So remember, I was allowing 1 request per second. I've just issued 6 in that 1 second. But because, remember, I initialized my server with a burst of 3 requests, the first 3 requests went through just fine. I'm using up a buffer. I'm using up a burst right there. Here's the second burst that I'm using, and here's the third. So that's my 3 request bursts. And then the moment I run afoul of it, I get back 429. Because remember, I'm issuing 6 requests all in the same second. I exhaust my burst request of 3. And then now, the moment I try to submit more requests within that same second period, then the server starts giving me back 429s, too many requests. And this is exactly what happened to me. So now, right, Johnny, this is amazing. Now I know how to rate limit people. I know how to stop people from taking over my server and using up all my resources, right, and creating chaos. That's great. But Johnny, I still want to be able to get through my work, right? Like, what if the server is sort of finicky, or what if, I don't want to be able to have to adjust it. I want to be able to take advantage of bursts without having to, sort of drop things on the floor. Like, how do I go about this? How do I build a resilient client for this situation? I hear somebody unmuted. Somebody got a question?
Yeah, somebody has a question in the chat.
Yes.
Should I read it out, or can you read it?
Yes, please.
Okay. So Maxine wants to know, how would you limit the number of requests per IP address?
Oh, again, I think I mentioned earlier, let me just actually, let me just leave the server running. And so I mentioned earlier, right, Let me just close this. That again, this is a very rudimentary sort of rate limiting implementation, right? So if you want to maintain state, right, for every client making a request so that you can do per client rate limiting, absolutely, right? So you want to do something in memory here. Maybe you have a map that you basically, maintain the number of requests, right? You might have to use a mutex, which does add some overhead, right? Because you have to lock and for the right to happen and things of that nature, that may add some overhead. But or maybe you want to sort of externalize that to a different storage mechanism, in-memory storage mechanism. Maybe you want to use something like Redis or other. Maybe Redis is not the darling it used to be these days, but some other in-memory, server, whatever it is. However you want to track state, right, for a particular client's rate limiting, right, you can absolutely do that. If you want to do it based on IP address, absolutely you can do that, right? IP address may not be one of the best ways because you might have multiple clients going through, that's sort of some sort of NAT translation layer that being a bunch of requests coming through from the same IP address might not be the best way to do it. But if you know for sure that, okay, you're only going to have one client behind a one IP, you can certainly do that, right? But the idea is you can introduce state for tracking of your client rate limiting here, however you so choose. You just have a mechanism to tracking for this particular client. Usually, clients when they make a request to your backend, maybe they have a bearer token in the header or something like that, some sort of authorization that allows you to identify exactly who the client is, what customer it belongs to, what user it belongs to, something like that. You can use that, right, as part of your state tracking for a particular client. Okay. All right.
Johnny, at that point, would you just recommend putting Caddy in front of your server and letting something like Caddy do this complicated stuff? Because that's how I always feel. Like, if I code this, I can probably get it wrong. If I put Caddy in front of it, I can configure Caddy to deal with this stuff.
Yeah, absolutely, absolutely. You could definitely sort of offload. You could offload most of this to something like Caddy, right? It'll handle it for you out of the box, right? Or with some configuration. You can turn it off or however you want to configure it, you can certainly do that, right? So that is definitely one of the things you need to consider, right? When trying to implement something like this. However, it's always good to know, right, how this stuff works under the hood, because something similar, right, is happening with those sort of prepackaged pieces of softwares and services. So this is sort of the how it works under the hood sort of implementation.
What I find funny is I'm not a good ops person. I tend to code things more because that's what I feel like I can control. But when I meet ops people, they're like, why are you coding that? We could just do it like this, right? So I think sometimes it's like if you're strong ops, you find opsy solutions first. And if you're a stronger dev, you kind of reach for the dev solutions first.
Makes total sense. Makes total sense. So here's one thing that I think we'll all agree, right, is something that everybody should know how to do, right? Which is basically how do you deal, right, with a server that has that provides, right, that allows you certain number of requests. Otherwise, you're gonna start getting throttled, right? So whether so you're on the side of somebody who has to now integrate with this server. However they implement the throttling, heck, they might be using Caddy to do that, right? Or they might be using some sort of API, gateway, fancy cloud service provider, whatever it is, right? However they implement it, right? You're now forced to contend with that, right? So here we are writing our client, right, to talk to such a server. So let's talk about what's going on here. How do we set up this scenario? So we have a number of requests to make. That's captured here by this request count variable, right? We have 25 requests to make. We're gonna keep track of how many requests succeed, and we're gonna keep track of how many times we're throttled. Okay, those are some setup here. Okay, we're gonna be calling on our local server, which is still running. Okay, and then we're gonna be capturing, right, these. We're gonna make this get call, which is a little helper that's gonna, that helps us simulate the situation here. This get call is gonna take this URL, and it's gonna take the number of times it needs to make that particular request. So this get, let's look at it. This get basically again takes a URL and the number of times it needs to make this request, right? And it's gonna return, right, this how many times it's succeeded, how many times it got throttled, and any error, any happened. So I'm just iterating through, right, the number of times I'm supposed to make this request. right? Sleeping for a random amount of time, up to a second, right? And then making, right, HTTP request. So in this case, I'm just putting some header information in there. That way, when it gets listed on the server side, we can actually correlate those things between the client and the server. Okay, just putting some header information in there so we can see what's going on. Okay, and then what we're doing is basically saying, hey, if the status code that came back from this request, right, is 200, right, meaning everything went well, great. I'm going to increment the success counter. And if I got throttle, right, 429, right, I'm going to increment the throttle request, right? But notice here, I'm not doing anything to sort of salvage the situation, right? I'm just simulating that what happens, right? If I send too many requests, right? How many times would I be dropping things on the floor, right? Because I'm getting 429, right? How many times would I be dropping things on the floor because I hit against this constraint on my system, right? And then at the end, we're just gonna basically, print out the results here. Okay, so this is our first, right, attempt at this. This is where we're not handling any sort of, throttling whatsoever. So let me pull up. I'm gonna keep my server running on the left-hand side here. And where are we? So I'm gonna CD here, and let's go into the client side, and let's go into back off example. Okay, yep, this is the one. So I'm just gonna do a go run main.go here. So here I am making requests. I'm on the client side making requests. Look at the server side. You see on the server side? You see which one of my requests are getting rate limited? So I'm sending 25 requests. So the summary, you can see the summary at the bottom here. So let me expand this a little bit. It's so hard to see. There we go. That's better. So on the right-hand side, you can see at the bottom here, I have the summary, right? 15 of my 25 requests succeeded, but 10 of them got throttled. And if you look on the left-hand side, you can see which ones got throttled. Request number 6 got throttled, 7, 9, 10, 12, right? It's somewhat in sequence because I'm counting the sequences up in up and whatnot, but you can see that the server, right, when I exceed my allowance for my burst request, the server throttles me. It says, hey, I'm gonna rate limit this request. So request number 12, right? If I look at request number 12 here, right, you can see on the right-hand side, it says, hey, you got throttled, right? And that's true. So I, at least on the client side, know I got throttled. So what can I do about this? Well, still gonna leave our server running. We're not touching our server. It's not up to us. Our server is built, exposed to us. We can't touch the server, right? It's somebody else's server. What can we do on the client side? So now we're gonna take a different approach. I'm gonna comment out this version of the code, and I'm gonna comment the version of the code we really want. We want a request with backoff. So now let's collapse this version and let's talk about the one with backoff. I mentioned before that there are lots of libraries out there that do very fancy and sophisticated things with backoffs and retries and all that good stuff. That's all well and good. This right here is a this is a poor man's backoff schedule. This is me saying that, hey, I want to, if I get throttled, right, on one of my requests, I want to start going through this backoff schedule, which is nothing more than a list of duration values, right? I want to start going through this list until, right, my request goes through. So if I need to make a request, I get throttled, I look to the backoff schedule and says, hey, I'm gonna wait 100 milliseconds. That's the first wait. And I'm gonna make my request again. If I get throttled again, I move on and I say, okay, now I want to wait 200 milliseconds. If I get throttled again, I keep going on and on and on. And if I need to keep adding to this until I find my sweet spot, so be it, right? But this is a very rudimentary, right, backoff schedule. How do we use this backoff schedule? Well, some loops, my friends. So again, here I need to make, right, so I have 2 loops here, an outer and an inner, but in reality, you don't only have the one for the backup schedule, right? So I'm trying to make, right, my 25 requests. So remember, I need to make this call to this URL 25 times. That's why we initialize up top, right? So I don't want to drop the 25 requests. How do I make sure that before 15 of them succeeded, 10 of them did not because they got dropped on the floor? How do I salvage the situation? So I iterate over my backup schedule, meaning that I'm gonna make my request, right? Set my request header, just like I did before, right? Now I'm gonna basically say, hey, if I got a 200 OK, well, there's no need to wait on anything, right? I got 200 OK, I'm good. Let's break out of this loop. Let's handle the result. I'm good, right? If I got throttled, right, I simply increment the throttle count. But guess what I'm doing at the very end of this loop? I'm waiting on the current back off value, which on the first time I get throttled, it's going to be 100 milliseconds. So again, very simple, very rudimentary. Like you wouldn't think implementing a back off, schedule is like that simple. It's super, super simple, but it does the job, right? I see, Jock, what's your question?
Somebody else has a question in the chat, and I don't want to wait too long because it might be related to what we were talking about a couple minutes
Yeah.
ago. He wants to know, or they want to know, in case when we have both a load balancer and an API manager, do we still need to manage the rate of the service at the service side?
That's a good question, because remember before I mentioned that you might have, depending on how your service is being deployed, some of this stuff might be taken off your plate, right? Some of this stuff might be being handled for you. But remember, you are on the client side. This code is client side code, right? So this is you making a request out to some service. Now, whether the service is your own team service or whether it is some third-party service, there is still a chance that those services have some sort of safety mechanism built in so that if you start pummeling them with requests, they can throttle you. So this, just because you have your own service that you manage, that doesn't obviate you from implementing some sort of back-off strategy. You are writing client-side code that needs to talk to a server. And that's always, right? That's always a situation where you have to account for something going wrong, right? Heck, could be the network fails for some reason, right? Could be at this particular millisecond that you hit the server, it's in the middle of a reboot, right? And you need to try again, right? Or it could be that, for whatever reason, some hiccup, right? It gives you a 500 error instead of a 200 OK when your request is perfectly valid, right? There could be a number of reasons why you need to implement some sort of a retry strategy, okay? So you still need to understand how to deal with those situations because you don't control the service implementation. So in this case here, again, remember, I'm gonna sleep for the first time I sleep, it's gonna be for that 100 millisecond duration, and I'm gonna make the loop again after the sleep, right? So the next time I come, if the same thing happens, guess what? I'm sleeping again. This time I'm going to sleep for 200 milliseconds. So I'm going to keep doing that until my request finally succeed with a 200 OK, right? And I can break out of this loop. So let's actually see this in action. So again, my server's on the left side, still running. It's not mine to change. I can't touch it, right? So now I'm going to run the same main.go program, right? But in this time, I'm calling the get with backoff, right? And not the original get that has no backup strategy at all. So now here I am running this program. So you can see I'm getting throttled. The server's still rate limiting me, still getting throttled. And you can see that I'm backing off 100 milliseconds, 200, 400, sometimes up to 800, right? So, depending on how much time I need to account for here, right? I can come in here and keep adding to this within reason, right? If you have to keep adding, if this thing becomes like like a page long, then you've got a problem, right? And it might not be your problem entirely. It might be that you need to have a talk with whoever's providing the server. You might have a talk with them, right? Because if it's taking that long to perform a request, I mean, there's something going on here, right? So this strategy gives you something simple, right? You can implement without having to bring a third party into your world, right? And you can see the summary here at the bottom. The success count is 25. How many requests did I need to make? 25. I still succeeded, right, with the 25 requests, despite having been throttled 72 times, right? So you still got your job done, which is to make those requests, pass in the data, perform the transaction, whatever you need to do, you still got that job done. And hopefully on the other end, making those requests is idempotent, right? So if you need to make the request multiple times, send the same payload multiple times, send it multiple times, whatever the case may be. Again, this is something that you need to work out with basically on the other side, whatever the strategy is there. But you need to be able to make those requests because something could go wrong between the time your client makes a request and the server receives it, right? But you now have a strategy for handling situation where something goes wrong, be it a 429, be it a 500 error, whatever those cases may be that you need to account for. All you're doing is basically checking the status code and say, hey, is everything good? 200 okay? I'm great, right? If that's what you're expecting. Or did something else go wrong? Is it a 429? Is it a 500? Whatever it is, right? Did something go wrong? Did I need to try again? Okay. And all you're doing is sleeping for whatever the back off schedule value is at this time. Okay. All right. So I've covered all the major pieces that I wanted to. And if you have more questions, happy to stick around. But I know we're past time a little bit, right? We got started a little late, so it's all good. But yeah, any questions, comments, different ways of doing things. I know Bill likes Caddy to handle a good bit of the server side stuff here. The client side stuff is still your responsibility, however, right? So anything I can sort of cover or at least point you in the right direction to that we touched on today. Oh, wait, if you do need to get in touch with me, hit me up on Twitter or LinkedIn or wherever you do your socials these days, and I can at least point you in the right direction. But that is it for me.
Johnny, I didn't realize it's so silly now, like some things, that the context that the request gives you would cancel when the client disconnected. Like it's obvious now that you shared it, but my brain went, huh, I never thought about that.
Yeah, it's a great feature, I tell you. It's one of the best reasons we use a request context. It's awesome.
And I wasn't handling it in my little framework where I could just like say, don't send the response or log. So I fixed a little code with that. So I was like, wow. And I didn't know the experimental package had a rate limiter because everybody always jumps to GoKit for some reason. And I didn't even know that package existed. So that was kind of cool.
Yeah, a lot of those packages actually use the rate package in the standard library or the experimental library under the hood. So yeah.
I've never added that stuff. I always just threw it over the side, over the fence to the ops team. Good or bad.
Right.
Anyway, very cool, dude. I'm glad I was here.